Finally, some chips in this show. Sportster Paul here. We're with SolidWorks CAM, made by CAMWorks, and using an Avid Benchtop Pro mill, we're going to get some speeds and feeds figured out. Also another chance to play with SolidWorks CAM. As in the other two parts I've fooled with, all the automatic stuff just got screwy. Let me see if I can show you here. When I let it make this ellipse in this part, how do we do this? It did all these plunges. I don't know what was going on. I cleaned it up and I wish I could remember exactly what I did. But for the most part, what's going on here, it goes in the vise at first like this. This is the first setup. A 3/4 inch hole, which of course it wants to use a drill, as if my little mill could even hold a 3/4 inch drill, or yeah, 3/4. And then this ellipse. The first one, I made a earlier test part. The ellipse was too tight, and a 1/4 inch end mill couldn't get in the corners. So how do I check stuff out? So I fattened that up. The things that I had trouble with SolidWorks CAM, stock manager. There's a thing to make the stock for this. I modeled the 3-foot long piece of angle iron I got from Home Depot, right? It's 6063, it's a little gummy, because they say right here, use a part file. So I, clicked on that, made the part file the thing. Unfortunately, it lines the edge of the part file right up to this edge of the thing. There's no way to move, I found, to move the stock relative to the part. So what I had to end up doing, once again, sketches, kludgy sketches, I went here and I made a kludge plane coming off 1/10 of an inch. I think this is, yeah, so the top plane was there. So I could just create a plane 1/10 of an inch in, and then use our favorite convert entities here and flash the cross-section of the angle iron onto the sketch. Then when you go into here, you can go stock manager, and instead of trying to use the real 3-foot long section that I thought would be cool to have, extruded sketch. And you pick kludge sketch, you say it's blind. I figured about 6-inch pieces I want to start hacking on. So I said 5/9 to allow for a saw curve. I got a cheap jet bandsaw that I'm cutting these up on. I kind of let the speeds and feeds, they're slower, and it does roughing, and well, let's go look at what it does. Rough rest machining finish, which is kind of silly when it's only one size end mill. Maybe that's why it took a very long time. What? I guess there's some trick I don't understand about showing the stock all the time. Well, oh, we're still in stock manager. There we go. I am dizzy with dialog boxes. So it roughs, it contours, then it cuts this back. Here SolidWorks CAM, because of their technology database and how smart it is, it decided, actually it did almost all of the cut, and then a tiny little, I said, well, let's even it up. So it cuts, so I went in and changed speeds and feeds and stuff, the contour, and went halfway down and then finished it off. Same thing up front here, went halfway down, finished it off. Then here, this is what SolidWorks decided when I calmed it down and just said rough that and then contour. Don't do whatever its automatic feature with all those plunges. And I let it choose the speeds and feeds. Then over on this side, I said, well, contour it and just hack the thing off. One pass. It's, I think, 0.128 is the thickness. Contour mill, the front, same thing, just one hack. Then a contour mill here. I said, let's try a spiral down into the 3/4 inch hole. And let's try a spiral into the ellipse. Things came out pretty good. The one mistake, I'll show a picture, because I had problems finding zero because of the tool probe in the Avid Benchtop Pro. it can't be on a conductive surface. It's meant for like wood and stuff. So I got to make a plastic base for that. So I found 0. I must have been a little high because it left a little shred of material here. Paper thin, it's tinfoil thin, but it left it and that's SolidWorks CAM just decided to make that feature. Where is it? Top ellipse. See, they just defined it as thick. There's no overcut or undercut. And maybe I said it better. No, see here, I said, no, undercut it. How about this one? See, this one, I said to undercut it. So all this automatic stuff, one day, automatic, everything, artificial intelligence, expert machine systems, machine learning, fine. But not for now. And I had the mistake of this thing. Once I said, I changed something and said, recognize features, and it went and put the drill back in and all the stuff that I took out first. At least it doesn't clobber anything you've already added, so that's good. The other goofy thing it does when you do automatic, it decides it has to come from underneath and hog out. Even though you told it the stock is this L shape, it feels it has to hog the entire bottom out. It has to come from underneath and hog, and take this big square out. It loves to cut air. I don't quite get it. I'm probably doing something wrong, right? I'm not a machinist. I'm an engineer. I'm still learning all this stuff. So that is the difference. Let's go to, oh gosh. Now, see, I always get confused between the two tabs. Contour. Okay, not the rough. Let's look at what the contour here is. I'll double click, and up comes feeds and speeds. 8,900 RPM and 24 inches a minute. So those kind of speeds and feeds, it changes around a little bit. For the one I did here, I say. So then over here, this one, let's double click on that. Here I said, I paid for a 24,000 RPM spindle. Let's go 16,000 RPM. And I want to bump the feed rates up, XY feed rate 44 inches per minute. And I'm going to keep getting more and more aggressive as we go. I'm going to be making one of these every couple days and posting a video. Seeing, I thought I had this horrible problem because there's this huge rough edge. I'm like, what did I do? Was it, did it climb instead of follow? Did conventional? Did I not have that Trico super $100 a gallon lubricant spraying right? I didn't find 0 right when I did the other side. So it's cutting air, and of course I forgot to turn the camera on until it was too late. It just cut air here, except for one tiny corner, and what I'm seeing that I thought was a screwed up end mill is the bandsaw that I used to cut this. So we'll learn about that next time too. But as far as surface finish, it does sound like there's some chattering going on. I'll leave it to you experts, and I promise not to talk over the audio of the machine, because I've seen people rightfully say, no, don't put music in, don't talk over it. We want to hear that machine running. So let's go and fire up. I'll clip in and we can see the cuts. It'll be, I don't know, 4 or 5 minutes. Here we go. Okay, so it did surprisingly well. I'm still learning the machine, right? This was the second part I made on that machine. I did this one, made a mistake because I made this rough and then forgot there was a 10,000th allowance. So this hole was undersized. This ellipse I made small. But then I got the brainstorm, hey, let's do both sides so I can make sure I understand how to do part 0 and how I can do 2 different setups at least. And it lets us compare identical material, identical day, tool wear about the same. Let's look and see how it does. And I'll post some pictures. Let's post some pictures now, okay? Here's the hole that SolidWorks did the speeds and feeds. All right, not bad. Actually excellent. Here's the ellipse where it didn't plunge down far enough, but let's look at the surface finishes. It's okay, all right, not too bad. Here's a hole I spiraled down into. That came out pretty good. And then here's the ellipse I did, and I can see little stepping. To me, that looks more like machine interpolation, but we'll find out. If it goes faster and gets worse, you know, we'll see about our surface finish issues. And then, well, I can't, this side is all rough, you know, don't panic on that. I could show you this surface here, ignore the scrunched up one, real nice. Then on the back side, you know, the far side in the mill, as it was in the mill, surface finish for the CAMWorks selected speeds and feeds. And so then this here is the surface finish. It's got a few dings in it. And then this is where I went faster on those feeds and speeds. And it's got some little tear-ups towards the corner of the flange, where it meets the other flange. That I assume is because it's cutting this big chunk off. Learning machining as we go, probably should have hogged it off so that the big piece fell off and then done a finish pass. So live and learn. Let's look real quick. That was here, right? This is the second one. Double click it. And on those, I went 16,000 RPM, 1,000 surface feet per minute, 64 inches a minute, taking 2 thousandths of a chip load. And here's some pictures of the setup, some pictures of the chips. Here's some pictures of, you know, I built this kind of, I took a tub from Home Depot, mounted the top of the tub down to the mill, then cut the tub in half so I could, you know, kind of make a container to keep the chips in. Well, with the Trico blowing air, chips went all over. So look, here's chips on the side. There's some chips, you know, a couple chips on the laptop keyboard. So my chip control methods aren't quite as good as I was hoping, but overall, even though I never got the parts to fix the second half of that Trico micro drop coolant, so I was only using one. Hopefully those parts will come in. They're lost. You know, the post office never got them. The people say they're supposed to come. I'm looking for alternates, but there's no O-ring on the container, so the pressures are all wrong. But there's so much of that lubricant. They say you hardly need any, right? Milliliters per minute or something. I wanted enough. I really cranked it open because I didn't want any problems. Oh, here's a picture of the end mill right at the tip. I don't see, I'm not a machinist. I'm not sure what I'm looking for, but it doesn't look, well, my buddies say all this dry machining, forget it. Even with coated end mills, none of that, they gum up on aluminum. And this is 6063, not 6061, you know, H6 or whatever, T6 heat treat. So it'll gum up even worse. So I didn't want to drag out the WD-40, but hopefully we got something going for you. Hope you learned. Like I said, we'll try another one. I'll try to fix my part 0 offset, figure out how to locate this in space and set up a stop so that makes sense. I'm really enjoying myself because now I'm getting to use the mill and learning a whole bunch of stuff about speeds and feeds and getting confident. It was scary to press that button. I did it up in the air once. It's like, I think it's doing what it's supposed to do. And I moved it down about 1/8 of an inch or a little higher above the part, did that again. It's like, yeah. I did have a problem. They pull up so high, it would hit Z limit. and in the Mach 4 controller would say you can't hit Z. And I got it down closer and could kind of see what was going to happen. I'm happy so far. We'll do some more of these about speeds and feeds. Plus we got other CAM packages to look at. That's going to be going on. So stay tuned. Hope your CAM fun keeps going. Hope you make some chips too. We'll catch you next time. Bye now.